A radical equation is an equation in which the variable is part of the radicand. That means your variable will most likely be on the inside of your radical. To solve these types of equations, here are our steps. We are first going to isolate the radical. That means it's going to be by itself on one side of the equation. After the radical is isolated by itself on one side of the equation, then to get rid of a square root, what's the opposite of a square root? It's to square something. So to get rid of a square root, we're going to square both sides of the equation, aka raise to the second power. Let's do an example. Actually, let's do a couple examples, and then we'll go fill in those same rules on our notes sheet here. Let's look at A. I like to highlight where my radical is so that I can see what's underneath it and what stuff has to move. Clearly, that -5 is on the outside of my radical, which means I need to move it to the other side. And to do that, we are going to use reverse order of operations, which if order of operations is PEMDAS, reverse order of operations is SAD-MEP. That means subtraction, addition, division, multiplication, exponents, parentheses, in that order. So I'm going to draw my little railroad tracks just like I was doing at the way beginning of this year. I'm going to do the opposite of subtract 5, which is to add 5. Oops. And I get that the square root of x equals 3. Good? That's step 1. Now the radical is isolated. Step 2 is to square both sides. I'm going to take the left side and square it, and the whole right side and square that. When I do that, radicals cancel out. So on the left side, the square root of x squared is effectively going to cancel out that radical, cancel out the square. The only thing that's going to be left in there is whatever was on the inside, which is x. On the right side, 3 squared, we do that like normal. 3 squared is 9, and that's solved. Questions? Okay. Look at B. We're going to do it again. My first step is to isolate. Here's my radical. Is that radical isolated? What I mean isolate, I'm meaning that the radical is the only thing on one side of my equation, which it is. There's the stuff that's inside the radical, but there's nothing else on the left side of that equation outside of the radical. So step 1, isolate, is already done for me in this problem. Step 2 is to square both sides. So I'm going to take the whole left side and square it, and the whole right side and square it. On the left side, square cancels out square root. So all that's left there is 2x minus 3. I'm not changing those numbers at all. I am literally just getting rid of the square root. On the right side, 9 squared, 81. And that's my step 2. Sometimes we get a nice easy problem like we did in letter A, where we do the squaring and we already get our answer, x equals 9. However, I don't know what x equals yet. So my third step is going to be isolate the variable. And again, we're going to be using reverse order of operations, SAD-MEP, subtraction, addition, division, multiplication, exponents, parentheses. So I'm trying to get this x alone. I'm going to divide it up like railroad tracks. And I'm going to do plus 3 on both sides. And divide by 2 on both sides to get a final answer. Questions on that? Okay, now that we've seen all three steps, let's go fill that in really quickly. A radical equation, again, is an equation in which the variable is inside of that radicand. And then here are our steps. Number 1, what should our first step be every single time we do one of these problems? Isolate the radical. We do that using reverse order of operations, SAD-MEP. Once that radical is isolated, what should our second step be every single time? Square both sides. Squaring both sides will cancel out the radicals. Once we cancel out the radicals, then we have to make sure that the variable is isolated. So we're going to isolate that variable one more time. Usually, that's just using reverse order of operations again. We are not going to see this yet, but I'm going to give you a little sneak peek of what we're doing tomorrow. Sometimes that requires factoring. Okay. Today we should be able to do these first 2 examples. So if you want to go back to those later, we can go back to them. Let's, for right now, go back. Oops. Go back. Oh, hello. What should we do first in letter C? -4. Perfect. Then what? What's that 3 doing to the radical? Multiplying on the outside. So to undo it, I'm dividing everything by 3. This is 4 square root 3x minus 2. Notice, I'm not changing anything inside that radical. I cannot touch anything inside of a radical until I've gotten rid of that radical. Nothing inside your radical should ever change until it's gone. From here, what do I do? Square both sides. On the left side, I should have 16. On the right side, I'm not changing anything on the inside. It's just 3x minus 2. That's step 2. And step 3, final step, I need to isolate this x. So I'm going to add 2. And I'm going to divide by 3. Any questions there? Okay, next one's a little bit weird. Look at this one. First step is what? +6. Okay, I'm going to zoom out. Do we notice something different about this problem as opposed to all of our other problems so far? Jacob. It equals a negative. Have we ever been able to have a square root equal a negative number? Remember, this is because, and I'm going to put a little thought bubble on the outside. If we square a number, let's say I take the number 2 and I square it. 2 times 2 gives me a +4. Okay, Miss Lees, but what if you square a negative number? Well, -2 times -2 is also +4. Is there any way I can ever multiply 2 numbers together that are the same number and get a negative number? No, because one would have to be positive and one would have to be negative, making them different. So, if this number is isolated, it has to be all the way isolated first. Then this cannot be negative. So our answer is no solution. We have to isolate first because sometimes you might get a problem that looks like it might be negative, but we actually end up making it positive as we do our isolating. Okay, any questions on that side? flip it over. I'm going to make it one step harder for us right here. If I take a look at these radicals, are they each isolated on their respective sides? There are no other numbers with those radicals other than the numbers that are underneath them, yes? So in this case, step 1, which is isolate, is already done for me. Step 2 is to square both sides. If I'm squaring both sides and both sides have radicals, then when I finish squaring them, I should have no more radicals. So this looks like 3g plus 12 equals 5g plus 7. Good? Now I'm solving for g. There's a g on each side of my equation, though, so how do I solve this? We want all of the variables to go to one side of my equation. It really doesn't matter what side you put it on. I like to try to avoid negative numbers if I can. For this problem, I'm going to choose to move the 3g to the right side. So I'm going to do that. It's a positive 3g, so I need to do the opposite, which is minus 3g from both sides. And then I'm just solving this like normal. I'm going to minus 7. And I'm going to divide by 2. I really like improper fractions. If you wanted to write this as the decimal 2.5, I would take that. I really, really like simplified improper fractions. Any questions on this one? So when I look at letter B, what do you think we're going to do first? Yeah? Yeah, we're just going to square both sides like this because they're already isolated. There's nothing else other than the radicals. So this becomes 3x over 5 equals 2x minus 4. Okay, we're going to pause here. I'm going to think about SADMEP. What the heck is going on? I'm going to do subtraction, addition, division, multiplication, exponents, and parentheses. I know based on last problem, I want to move all of my variables to the same side. However, can I move this 3x the way that it is right now? No, because fractions are like the P in SADMEP. They're parentheses. That means I cannot do anything to it. It is trapped until I move this 5 by multiplication. So that side is nice and done now. That's 3x. However, this is an important part. If I have 2x minus 4 times 5, guess what? Both of those things are getting multiplied. I'm going to multiply the 5 to the 2x, making 10x, and I'm going to multiply the 5 to the negative 4, making 20. We have to distribute here. Questions on that? The rest of the solving should be pretty normal. If I were you, I would move that 10 over to the left side. So I'm going to move this by subtracting 10x to get negative 7x equals negative 20. And then I'm going to divide both sides by negative 7. I see this all the time on your quizzes, and I'm not entirely sure why. A negative divided by a negative is not a negative number. It should be a positive 20 over 7. If you wanted to do a decimal and get like 2.8, I think, something around there, you can, or you can just leave it as 20 over 7. Any questions on this? I have an application problem that we absolutely have to get through, and then I have a challenge problem that we're going to try our darndest to get through. Let's look at the application. The formula for speed of a falling object is v equals the square root of 64d, where v is the speed of the object in feet per second, and d is the distance the object has fallen in feet. That is fancy words for saying Here's the equation. V stands for speed, D stands for distance. Okay, that's all that says. Then it says, what distance has an object fallen if its speed is 150 feet per second? So we're going to all annotate this problem real quick. If it's asking me what distance has an object fallen, what variable am I looking for? What variable am I solving for? D. Perfect. And then if it says its speed is 150 feet per second, what variable is that? V for speed. So I'm going to take this equation right here. I'm going to plug in the speed that I know, and I'm going to solve for D, which is what it's asking me to find. So I know that this is 150 equals the square root of 64D. How do I solve this? Step 1, is it isolated? Yes. So step 2 is square both sides. 150 squared is 22,500. And then the square root of 64D, square root and square cancel each other out. That's just 64D. I divide by 64, and I'm going to get the super duper pretty number of 351.56. I should be writing my answers in terms of what the problem is asking me. So it's asking me what distance has it fallen. That's 351.56 feet. Not too bad. Last one. This will not be on your homework. I'm not going to actually test this on you, but it may show up as a bonus problem if it does show up. So let's lock in on this. Ready? Take a look here. Remember in the first two problems of this page, we were able to square both sides because both sides were both isolated. But I have this 2 on the right side. If I subtract that 2 over to the other side in order to isolate it, is the left side then isolated? No matter where I put that 2, one of my 2 sides is not going to be isolated, right? It's unfortunately just going to end up where it is. So here's how we do this. We are going to act as if it's isolated, it's isolated. So I'm going to square both sides. On the left side, that's nice. What should the left side be? Perfect. Okay, hold on. Left side, done. No worries, no sweat. On the right side, though, this gets tricky. We saw this in 10.3, so 2 lessons ago, we saw this. When I have 2 terms, okay, and they are squared, that's my signal that I need to expand this into 2 bubbles for multiplication. So I'm going to rewrite this as 2 minus the square root of x times 2 minus the square root of x. Okay, then just like we did in 10.3, because we're not forgetting our radical rules yet, we are going to distribute those 2 binomials. That means it's going to look like 2 times 2 is 4. 2 times negative square root x, the 2's on the outside, the x is on the inside, so they can't go together. It's just negative 2 square root x. Same thing for this guy, negative 2 square root x. And then, if I have negative square root x times negative square root x, 2 negatives make a positive, and then what happens to those square root x's? If I multiply square root of x times square root of x, I get just x. Remember, that's our rule. If we multiply a radical times itself, the radical goes away. Let me drop that x plus 1 down. And then guess what, my friends? We're going to combine like terms. We're adding and subtracting, just like in 10.2, I think. Yes, 10.2. So I can add together those like terms. negative 2 radical x and negative 2 radical x make negative 4 radical x. I'm going to drop everything else back down. And then, oh my gosh, we have a brand new problem. This is exactly like all the problems on the front page. We're going to isolate this radical, and then we're going to solve. So I'm going to start a new line over here. X plus 1 equals 4 minus. Okay, so I'm just rewriting this over here. Brand new problem. I got to isolate that radical x. What am I going to do first? Beautiful. That's x minus 3 equals negative 4 square root of x plus x. Then what? Beautiful. What happens to that minus x on both sides? They're going to cancel each other out. Negative 3 equals negative 4 square root of x. What's next? Beautiful. So this is 3/4 equals the square root of x. Now that my radical is isolated, what's my second step? Square both sides. So on the right side, that's just an x. And on the left side, do we remember fraction rules? What does that become? 9/16. We square the top, we square the bottom. Okay, let me zoom out so we can see the whole thing. Kind of a doozy, right? We did 2 problems all in one. Again, this will not be tested, but it might be bonus. Any questions on this?